Hello and hi, welcome to Saraswat classes. I'm solving the WebG chemistry paper 2022 and first question over here is a sample of MgCO3 is dissolved in dilute HCl and the solution is neutralized with ammonia and buffered with NH4Cl and NH4OH disodium hydrogen phosphate reagent is added to the resulting solution. A white precipitate is formed. What is the formula of the precipitate? So for this particular question, what is the scheme of the reaction? We have MgCO3 plus dilute HCl. So that means what we will get over here. Some carbon dioxide will be liberated. Mg2 plus ions and the corresponding Cl will be formed in the solution. Now if you treat this with the buffer of NH4Cl and NH4OH followed by the addition of disodium hydrogen phosphate, a white precipitate is formed and the formula of that precipitate is what? It is MgNH4 plus PO4 3 minus. So answer over here is this one. We need to use VSEPR for answering the next question, which says HCF2NO2, HCN, COO2 and CO2. What are the structures? We have to say identify the non-linear molecule pair from the above mentioned molecules. So we will use the alternative approach. We'll find which ones are linear over here. So over here, suppose we have steric number. If it is 2, 3, 4, 5 or 6. Now for that the hybridization is going to be SP, SP2, SP3, SP3D, SP3D2. Okay, so for say CO2, we have total valence count is going to be 4 plus 2 into 6, that is giving 16. 16, the number can be divided by 8 because it is greater than 8. We have 2 and that gets cancelled. So for this 2, this is nothing but the bond pair. We can see hybridization is SP. Now what we will say over here is that C combines with oxygen using the single bonds and oxygen having valency 2, we will use another pi bond, and so the structure over here is linear. And then what we have, say HCN, even this one we know the structure is going to be something like this, so it is linear again. What about XeF2? Okay, what about XeF2? Now for Xe we know it is 8 plus 2 into 7 giving you 22. Number 22 is greater than 8, so you divide by 8. This number corresponds to bond pair. The remainder is less than 8, we divide by 2. This corresponds to lone pair. Both the number represents steric number. Hybridization is sp3d. So you put the Xe and you draw the lone pairs. Lone pairs are not considered while considering the shape of a molecule. So lone pairs using Bend's rule will be placed in the equatorial bonds, and the fluorine, which is most electronegative, will be placed in the axial bonds. So this shape over here that you can see, that is what? That is nothing but linear. So this also is your linear. Now, what we can do? This one is linear, linear. This is also linear. What the question says? Identify non-linear molecular pairs. So which ones are left? NO2 and COO2. Okay. So these are my answer. Even if you want to know what is the shape of this molecule, again that can be found out from using VSEPR. So for NO2, this is the shape, and for ClO2 also, which is again a odd electron molecule, that is the shape. Okay. Number of atoms in a body centered and a face centered. For that, let's draw some cubes. So this is the cube for FCC. All right. So for FCC, we know corner atoms are occupied, for which 1/8 contribution is there, and the face center, top, bottom, left hand side, right hand side, behind, front. So these face centers will make a contribution of half. Corners make a contribution of 8. So Z is what for FCC? 8 into 1 by 8 plus 6 into half. Total is 4. What about for the BCC? We will say, again this cube we will draw. So in a BCC, again the corners will be occupied and so corners are occupied, making 1/8 contribution, and the one in the center is occupied. So over here, Z is what? 1/8 into 8 plus 1. Okay, so that will be equal to, we will say, all total 2. So the correct answer over here is going to be 2, 4 for body center and face centered cubic unit cell respectively. Number of unpaired electrons in the Mn2 plus ion. Okay, this ion. So what is the electronic configuration of Mn2? Mn itself, which is having 25 electrons, we will say that is equal to Ar 3d5 4s2. Now when this becomes or loses 2 electrons, becomes Mn2 plus, and that is nothing but Ar 3d5. If you draw the d orbitals, it means 5 such boxes of equal energy should be present. So this is your 3d. Each one is having 1 electron. So 5 unpaired electrons are there now, and our answer will be C. Average speed of H2, let's call this as C average H2, and that will be nothing but 8RTE1 by pi mH2, and C average, that of O2 at T2, is going to be 8RT2 pi mO2. If these two speeds are equal, find the ratio of T1 equal to T2. So what we will do, 8R T1 pi, so this is basically 2 pi, because the value of mH2 is 2, and 8RT2. This is 32. So we will say this is nothing but 32 pi. Right? So that is what we will say. So basically, after equating, what we can say, we can remove this root. The 8 and R are gone. Pi is also gone. So we have T1 by 2 and T2 by 32. So basically T1 by T2 will be so the ratio out here is going to be 1 by 16, and we do not see an option over here that says T1 by T2 ratio is 1 by 16. So maybe one of the options over here is not correct. Sodium nitroprusside, just have to remember that over here, find out the nitrosyl ligand, which is having +1 charge, and the iron should be over here in +2 state. So out here, as we can see, this is nitrite, this is nitrate. So both of these options are wrong. Either C or B can be the correct option. If we calculate the oxidation state now, so this is X, this is -3, because the counter ion sodium is having +3 charge. So this is -5 +1 -3, and X is equal to +1. Okay. If we calculate for here, it is X -5 +1 -2, and X comes out over here to be as +2. So here this is wrong, this one is wrong, and this one is correct option. Choose the correct statement for the NiCN4 2- complex. This is a very this question has come many a times. Okay, the thing to remember out here is to calculate the oxidation state, and this will be equal to +2. So nickel 2 means over here a D8 system. If 4 ligands are present, complex may be tetrahedral or square planar. Okay. Now, when strong field ligand are present, such as CN, the complex is obviously square planar. Now, that being the case, the square planar splitting is going to be something like as shown. This is dxy, sorry, this is dxz, and dyz, this is your dxy, this is dz square, this is dxy, and that will be dx square y square. So if you now put the electrons over here for a d8 system, 1, 2, 3, 4, 5, 6, 7, and 8. So as you can see, there are no unpaired electrons, so this will be a diamagnetic system. Okay, so the correct answer here is square planar and diamagnetic system, and that means this one. Boiling point of water is higher than liquid HF. The reason for that is obviously we will say hydrogen bonds are larger in number in water. Now, how can one show that? We will just write a water molecule. So this is now in hydrogen bond with another water molecule. That is in hydrogen bond with another water molecule. Like that. So there are basically for each water molecule 4 hydrogen bonds. What about the HF? So we can see for each HF there are 2 hydrogen bonds. Okay. The metal pair that can produce nascent hydrogen in alkaline medium, obviously zinc and aluminum. Okay. The ones that form amphoteric oxides, generally they can form the nascent hydrogen in both acidic and alkaline medium. The correct bond order of BF in BF3 molecule. Now, for this type of, we will say bond order is number of bonds between two atoms divided by number of resonance structures. So as we know, for a BF3, so if this one goes in like that, we will say this is one structure. If you donate this one, then if you donate that one, then what will happen? So if you just take one such bond connection between two atoms, say this one. So how many number of bonds we see? We see 4. Okay. We see 4. The number of resonating structures, we will say 1, 2, and 3. So obviously it comes out to be 1 by 3. And so the answer over here is going to be that one. Which of the following is radioactive? Obviously we will say tritium. Correct acidity order of the hydroacids will depend on the bond length. So if you have high bond length, and that will be directly proportional to the acidity. So over here bond length increases down the group, and so we will say acidity increases from HF to HI. To a solution of colorless sodium salt, lead nitrate was added to have a white precipitate which dissolves in warm water and reprecipitates on cooling. Which of the following radical is present in the salt? Now out here the answer should be lead chloride. Okay, and PBS over here is black. Nitrates are highly soluble. Okay, and sulfates are insoluble in hot and cold water. So this behavior is only shown by Cl. Oxidation states of Cr2O7 of chromium in Cr2O7 and CrO5 respectively are, obviously we will say over here in the structure of CrO5 we can see this is the structure, it is like a butterfly. So this is -1, -1, -1, -1, that is oxide, so -2. So the X out here is going to be +6. In case of dichromate, this is minus, so this will be 14. Say this is 2x, alright, and this is equal to, we will say, since this is +2 and the whole thing is now neutral, okay. So what we can say, we will say it is going to be -12, 2x equal to 0, or therefore x value will be equal to +6, and so we will say the answer over here is this one. Now the relative stability of the radicals over here, if we consider, we have a group that is having -I effect, okay, now over here again we will use VSEPR to predict the answer of this molecule. So over here carbon ion we can see that is CH3 minus, so total valence electron count is going to be 4 plus 3. For the negative charge we have +1 equal to 8. 8 number is not greater than 8 but equal to 8. All less than 8 we divide by 2, so this is going to be 4. And as discussed in the solution of this particular paper, whenever the static number is equal to 4, the hybridization corresponding to that will be sp3. Similarly, we can consider this group over here also as a 1 electron donor, okay. So for that also we can see the total valence electron count for this one is going to be similarly 8, and hence this also will be having the hybridization as sp3. So we will say the answer over here is going to be both sp3. Let us look at the molecule or question 57, and as you can see we have to find out the correct relationship between the molecules 1 and 2. So in both the cases we can see that the hydrogen over here are having opposite relationship to each other, right? Or they're lighting the opposite sides. Okay, that is one thing. Now, so this is not going to show any type of geometrical isomerism. They are, in terms of geometrical isomerism, they are same. Okay. Now let's look, because this particular center is a chiral center. Okay, are they having any mirror images or they are same? We have to find out. Cannot be a diastereoisomer isomer now. Okay, so let's see that part. Now if you think that using Fisher rules, that if this is as a group going here and this as an atom going here and this as a group going here, so at a time if you rotate 3 groups or atoms, the configuration of the molecule remains the same. So what will happen if we do that? We will be generating this particular molecule. So in that sense we can say 1 and 2 are both identical molecules, or they are homomers. The enol form in which the ethylene 3-oxobutanoate exists. This is what we have to find out. So let's. Okay, the question is the enol form in which the ethyl 3-oxobutanate exists. 3-oxobutanate is this particular structure over here, as you can see. Okay, this is your 1, 2, and this is 3. And this is the ethyl. And this is the oxo part. Okay, because this is a ketone. Now this one, if you want to think of its tautomer, then so this is the enol. Just let me. Now this is the intermolecular hydrogen bonding because of which this enol will form. This is the enol and this is the ketone. So this 6-membered ring stabilizes the enol or increases its content within the equilibrium mixture. Now comparing that, the structure that looks very similar to this. So this is 1, 2, 3, 4. Obviously, as we can see, this is the hydrogen. So this is lying opposite, right? This one and that one is lying opposite. So this one will not be the correct option, neither this one. Okay. So we have to look for a structure in which this OH group and this group over here, they are lying on the same side, and that should be this one and that one. So obviously correct answer over here is going to be C. How many brominated products, including stereoisomers, would be formed in the free radical bromination of N-butane? Okay, fine. So N-butane we know is having this structure. Now, if you think this is CH3, this is CH2, CH2, this is CH3. There are two types of hydrogen over here. Monobromination they are talking about. Okay, so obviously we can think of one that is like this. Now that will be two hydrogens over here, so there are no optical isomers possible here. But for the other one, in which we have this one, here because there is a chiral carbon, so there are two such optical isomers possible over here, one over here. So in total 3, and our answer is going to be over here 3. Correct order of acidity of salicylic 4-hydroxybenzoic acid and 2,6-dihydroxybenzoic acid. So over here the question is regarding ortho effect. Okay, and we know as we keep increasing the groups in the ortho position, we increase the acidity. So this one, because of ortho effect, will be more acidic than the salicylic acid, which is that one. Okay, which will be more acidic than the 4-hydroxybenzoic acid. That is the one. So we will say the answer for 60 is going to be 2,6-dihydroxybenzoic acid, salicylic acid followed by hydroxybenzoic acid. How much solid, in question number 61, oxalic acid has to be weighed to prepare a 100 ml, exactly 0.1 normal oxalic acid solution in water. Now we know that normality is molarity into N or N factor. Oxalic acid is dibasic. So N factor is equal to 2. So we will say molarity is 0.1. Okay, so that is going to be 0.05 m. Now what is the millimoles of oxalic acid present in 100 ml? We can simply do that by volume into concentration. That is nothing but 100 ml into 0.05 m, and that is going to be 5 millimoles. Now we know the molecular weight which is given out to be 126 gram, and that is the weight of 1 mole of oxalic acid. So the weight of 5 millimoles will be 5 into 10 to the power minus 3 moles into 126 grams and that will come out to be basically, let's calculate, 0.63 gram. Okay, so answer over here is going to be, sorry, the major product of the following reaction over here, obviously this is going to get protonated if we think that way, and that will lead to the formation of the most stable carbocation. So if you think in terms of stable carbocation, then obviously this will be the most stable carbocation, and not this one. Okay, not this one, because of the minus I effect, less stable. So this is not the correct one. So now if you add Br minus, your answer should be sorry, which means this one. The correct order of relative stability of the following conformers of butane. Obviously this is, one is anti-staggered, most stable, and over here this is having gauge butane interaction, both of them, these two. So 1 and 3 are of equal energy and less stable than anti-staggered. So our answer over here is going to be this one. In question number 64, we have been given molecular C6H6 plus 15 by 2 O2 gives you 6 CO2 plus 3 H2O. Benzene burns in oxygen according to the above equation. What volume of oxygen at HTP needed for complete combustion of 39 gram of liquid benzene? So now we have to first find out the molecular weight or molar mass of benzene, which is 6 into 12 plus 6 into 1. Now that is going to be 72 plus 6, that is 78 gram per mole. Now number of moles present in 39 grams of benzene is equal to weight given, that is 39, divided by molecular weight, which is nothing but 39 grams by 78 grams per mole, and that is equal to half mole. Okay, that is equal to half mole. So now, as you can see over here, 1 mole is using 15 by 2 moles of oxygen. All right. So we will say 1 mole of benzene uses 15 by 2 moles of O2. Half mole of benzene uses 15 by 2 into half. That means 15 by 4 moles of O2. 1 mole of O2 occupies 22.4 liter at its TP. So 15 by 4 mole occupies 22.4 liter into 15 by 4, and that should be equal to 84 liter. Okay, so this is the answer now. Avogadro's law is valid only for the ideal gas. Okay, it is only valid for the ideal gas because there is volume correction in van der Waals gas or the real gas. Okay. Next question is, okay, question number 67. We have been given de Broglie wavelength of electron, proton, and helium 2 plus ion, that is alpha particle, are in the following order. Speed of E, P, and alpha are the same. So speed is the same. That means we will say lambda equal to 1 by mv. Okay, this is v. V is the velocity, because we know, according to de Broglie's equation, h by mv, that is lambda, and m is mass of particle. That is equal to m. So what do we know about the mass of electron, proton, and helium particles? So if we say mass of helium particle, so that is going to be 4 times the mass of, so alpha particle we know its mass is 4 times that of the mass of a proton. For proton, that is nothing but mp. For electron, we will say this has to be almost like 1836. See, so the mass of the electron is the lowest. Okay, so we compare mass of electron, proton, and alpha particle. This is the lowest, and this is the highest. And we know velocity for each of them are to be equal. So we will say lambda therefore is only dependent on the mass of particle. Higher will be the mass, lower will be the wavelength. Okay, so the lowest wavelength will be for the alpha particle and the highest wavelength will be for the electron. So we will say this will be the correct answer. Question is given in 68. 1 ml of water has 25 drops. Let N0 be the Avogadro number. What is the number of molecules present in 1 drop of the water? Density of the water is given to be 1 gram per ml. So we will say over here, since we know 25 drops is equal to 1 ml, right? So 1 drop, its volume is 1 by 25 ml. Okay, this is what we know. So we can say now the mass of 1 drop of water is volume into density, and that will be 1 by 25 ml into 1 gram per ml, or 1 by 25 gram. We know what 18 gram of water equals to N0 molecules of water. That is the Avogadro number of molecules of water, or 1 by 25 gram of H2O will be equal to that is equal to 0.04 by 20 by 0.04 by 18 NO, or that we can say to be equal to 0.02 by 9 NO. So the correct answer will be this one. Bohr model of atom, radius of hydrogen in the ground state is R1, and the radius of helium in the ground state is R2. Which of the following statement is correct? Okay, so we know that for board-like atoms, the radius is basically n square by z. N is the orbit or the principal quantum number, and z is the nuclear charge. Okay, so what is the sum? R1 by R2 we have to find out. So what is R1? Ground state means 1 square by 1. What is R2? Again 1 square by what? 2. So that is 1 square by 1. All that is equal to R1 by R2 is this, or we can say R2 by R1 is what? 1 by 2. So our answer over here is going to be this one. Which of the following is the correct set of 4 quantum numbers NLMS? What we know is that for any value of n, L will range from 0 to n minus 1, okay? And for any value of L, ML will range from minus L, 0 to plus L, right? Of n, okay? So if you look at that way, for 0L, minus 1 can't be there, so wrong. For 1, minus 2 can't be there, wrong. For 3, yes, minus 2 can be there. And for 2, minus 3 can't be there, so B is the correct option over here. Next, we have been given, let the CRMS speed of H2 at this much temperature, that is 150 Kelvin, at what temperature the most probable speed of helium will be half of the CRMS. We have to find out. So according to the sum, we will say CRMS H2 is half C most probable HE. Alright, so that would mean basically this is half 3R T1 by MH2 equal to 2RT 2 MHE, where T1 I am taking out to be as 150 Kelvin and T2 I do not know. Alright, so that means this will, if this goes inside, that will be 8R T2, and this is 2, no, this is 4, and this is around 3 into R, sorry, into 150 divided by 2. So that is like 75 into 3 r equal to, if you remove the roots, 2r/t2, right? So r and r goes away. This is basically 75 so let's calculate. This is like into 75 into 75, sorry, like 75 into 3 divided by 2. So that is going to come out to be as 112.5 Kelvin. Our answer over here is going to be this one. Correct pair of electron affinity order. Okay, always fluorine is less than that of chlorine. Electron affinity, not negativity, okay? And also remember that second period elements have lesser electron affinity for similar reasons used for why fluorine has less electron affinity than chlorine. So here also oxygen will be having less electron affinity than sulfur. So option B is the correct option over here. Okay. Next we will say in this particular question number 73 over here, what will happen in the first step? Let's check. We have been given Br, Cl, CBr bond is more weak. So the moment we use Mg, ether, okay, it forms this one. So here is a minus charge over here. Now if you're using 4-chlorobenzaldehyde, right? Attack here, this will open up. So basically we're having a compound. Something of that sort. And then if you use NH4, Cl. Okay, so we will have this one, A. The product of the following hydrogenation reaction is going to be, since they're using one equivalent and one equivalent of hydrogen, then our answer is going to be D. Okay, now here the question is the correct statements about B2H6 is, okay, let's check. So for this we need to know the structure of B2H6. The hydrogens now I'm drawing are called terminal hydrogens. The ones I'm drawing now are called the bridging hydrogens. So technically we will say that B2H is having two types of hydrogens, okay? So these are the circled ones are called terminal ones. Okay, terminal. Alright. And the black ones, let's make this black. These are the bridging ones. It contains a 3-center 4-electron bonding, yes it does. And this is the 3-center 4-electron bonding. This is called the banana bond. True, true. All the atoms over here, B atoms are sp3 hybrids. Yes, this is also true. The molecule is not paramagnetic, rather it is diamagnetic. Which of the following, question number 78, would produce enantiomeric products when reacted with methyl magnesium iodide? Okay, let's see. Benzaldehyde means what? If you react with methyl iodide, followed by the acidic workup. Because this is going to attack. Okay. And what will form? So after acidic workup, so this is sp2 carbon, right? Attack can take place from top and from bottom. And if there is a generation of a chiral center, then it will lead to the formation of optical isomers. So this one, both plus and minus will be formed, okay? What about the propiophenol? Again, if we attack top and below, both are possible. And this is your Me. Acidic workup will give you both the plus and minus products. But in case of acetone, not possible, because as you see from the structure of acetone only, if you attack with one more CH3 minus, okay, and this opens up, there are 3 equal, so not possible. Even in case of acetaldehyde, there is already a methyl and you are attacking with the methyl. So the alcohol that will be produced will be having 2 methyl groups on the same carbon. So this is not possible, not possible, but these are possible. For this one, this is your Clemenchen reduction, this is the Wolff-Kishner reduction, and this is also going to reduce the molecule that is this portion to CH2. Okay, so these will be our answers for this one. And which of the following are incorrect?